Okay. Today yesterday we did the Pythagorean theorem. Okay. Today we're going to reverse it, converse of the Pythagorean theorem. If you have three sides of a triangle, do you know if it's a right triangle? You just use Pythagorean theorem. We're also going to look at some special triangles. They're called Pythagorean triples. They are all going to be integers. Do you guys know what an integer is?
Yeah.
What?
Any number that's not a any positive.
It's like pi something.
No, pi is not an integer. It's a whole number.
And it doesn't fit on
It's a whole number. No fractions, no decimals, and they're opposites. Now, you had a question on the homework about consecutive integers, so we'll look at that today.
Oh, that's easy.
We have to use FOIL. You have to multiply it out. Okay.
Foil, like tin foil.
First, outer, inner, last. Okay, so we're going to determine if triangles are right, apply the Pythagorean theorem in real-world problems. And later on, because I took so many pictures in Egypt, we're going to use some math to find out how tall the statues really are that are in the temples. Well, you'll see the pictures of me. I know how tall I am. And we're going to be able to figure out how tall the statue is. We're going to use some similar triangles. There's a couple ways to do it. You have to scale it.
Make Lily.
I suppose you could do that too. Never thought of that. Okay. The converse of the Pythagorean theorem. If, all those words, if you know that a squared plus b squared equals c squared, then you have a right triangle. Yesterday, what we did was we had right triangles, so then because of that, we knew that if I squared the legs and added them together, it equals to the square of the hypotenuse. Today, if I take any triangle and I try to use Pythagorean theorem, if I get a true statement that the square of the two shorter sides added together equals the square of the longest side, then I have a right triangle. Now, there are some special numbers, there are some special integers that work for triangles. If I know on my triangle one side is 3 and the next side is 4, if I know those two numbers, I know that the third side is 5. It's called a 3, 4, 5 triangle. You'll see it on the ACT. Pretty sure. Now, what bothers me about this is we don't know why their multiples work. Now, if I take a triangle, I want to see if I can do this. Okay, Cole, Zach. This is 3, 4, and 5. If I double all the sides, and I'll try to draw it reasonably correct. This is 6. That's supposed to be 8, and then this will be 10. If I double all the sides, that's another Pythagorean triple.
Isn't Pythagorean like 5 squared has no 3 squared plus 4 squared has to equal 5 squared?
That's right.
Yeah, got it right.
Okay, Pythagorean triple. But here's the deal. These are whole numbers. They're not decimals, they're not fractions, and they're not square roots. So it's kind of nice. So what you're going to do is all the multiples are also Pythagorean triples. The reason is because these triangles are similar. This is just double the little triangle. That's all. And when I do the ratios within the triangle, the ratios of the big triangle are exactly the same as the ratios of the little triangles. We'll do that later this year when we get into trigonometry. Second semester. Go. Oh, yeah, well, let me do the lesson, then we'll do those. Okay, so how can I find the triples? Okay, you really want to memorize these. I have them on the board over here. But how do they work? The odd numbers, and I haven't thought about the even one. I'm trying to remember how to do that, but I'll think about it. If I square 3, I get 9. What's approximately half of 9? 4. I take that and I take the next consecutive number. These are consecutive in this case. So what follows 4 is 5. So let's use that rule to do 5. I'm going to square that, which gives me 25. It's half of 25. We can't do it. It's 12 and a half, right? Or 12 and 13. Okay, guys? Because if you can generate these, you don't have to memorize them. If I do 7 and I square it, and I get what? 49. What's half of 49? About? It's about 50. So 24, and then what? 25. These are consecutive. You square this first number. So let's do 9. If I square 9, I get what? 81. Half of 81 is about 40. So it's 40. 41.
How did you do that? That's so cool.
It is cool, actually. So if I do 11, what's 11 squared? 121. Half of that is, make it 120. It's 60. And if you don't believe me, take your calculators out, square this, square this, square this, and see if the squares add up to the square of 61. They will. Now those are the odds. Now I don't usually know the 11s. I usually know these. And then you can double them and triple them. So when you get big numbers, divide by 2 or 3, try to reduce it to see if you get one of those.
Oh, it is 61.
Yeah, what? That's the rule for the odd numbers. The even numbers, the only one you really need to know is 8, 15, and 17. Because most of the time what happens is if you get a 12 here, it's probably a multiple of one of these. Usually that's what happens. So that's the one you have to know. If you double 8, you get what? 16, right? Take the numbers to the left of 16 and to the right. 15 and 17. Okay. I'm going to leave those on the board. It's not an odd. Only odds, yeah. That's why I broke it down. These are Pythagorean triples. I'll leave it on the board. But it makes life so much easier in the assignment if you recognize a triple is 10 times shorter. Because who wants to do Pythagorean theorem over and over again?
Is there an easier way to do it with
That's it. I think you double that and then you go number on either side of that number. Double 8, you get 16. It's 15 and 7.
Oh, what do you mean?
Well, actually, I think it's, if I square it, I get 64. Yeah, it doesn't work. It's not right. That's only true for odds. Oh, these are the only ones you need to know. I think we just double that and then you take halfway between those.
So you get 16.
And 16 would be here. One to the left, one to the right. I can look it up. I'll look it up for tomorrow. I'm trying to remember.
You're gonna have to use that thing.
No,
Alright.
this is just, you can,
Extreme Pythagorean triple.
yeah. This is either you memorize it or you remember the little trick about squaring and finding two numbers halfway. Okay. So, are these Pythagorean triples? Let's look. In other words, are they a multiple of what we have here? What goes into 25, 60, and 65? 5. So if I divide by 5, I'm going to get 5. What's 5 into 60? 12. 5 into 65, is anybody? 13. Is that one of my Pythagorean triples? There it is. Yes, it is. Any multiple. No, you like that. Do you want to get your calculator out and do 25 squared plus 60 squared equals 65 squared? Do you want to do that? I don't. It's much easier. What about that one? Is this a Pythagorean triple? Is that my list? Yes? Only if you click. No, doesn't work. So this is yes. And this is no. It has to be a multiple of what I have on the board then. That's all there is. So if I did 14, 48, and 50, is that a Pythagorean triple? Well, divide by what? 2. So I get 7, 24, 25. Yeah. Once you have two of the numbers on any right triangle, you always know the third. So if I know 9 and 41, and that's and I know for sure it's a hypotenuse. Then I know the other side's 40. It's really nice. Oops.
And we only need to know the first set of triples.
What you have on the board is what you probably should know. I don't even need to know the nines, but I found it very convenient. Okay, let's do this problem. This is an application problem. Okay, ready? Cole? There's my ladder. There's my building. Draw pictures when you get to these word problems, because the pictures aren't there. How high on a building will a 10-foot ladder touch if the foot of the ladder is 3 feet from the building? Okay, I need to put the numbers in here someplace. The building is a leg, the ground is a leg, and the ladder is a hypotenuse. Where does the 10 go? It says a 10-foot ladder. This is the 10. Now, it says the foot of the ladder, which is this, is 3 feet from the building. So this is 3. Is that going to be a Pythagorean triple? No. Because I would have to have a hypotenuse of 5. I wish it were. So I can do the work. So what do you want to call the height of the building? What do you want to call this? X? I would have called it H, but that's okay. 3 squared plus x squared equals 10 squared. I wish I could do 3 plus x is 10. It'd be so much easier, but it's wrong. Okay, Cole, are you doing this?
Yeah, right now.
If I subtract 9 from 100, how much do I get? Zach? What do I get here? 91.
It's 10.440.
Can it be bigger than the ladder? Zach? Can this side be bigger than the 10?
Yes.
No. So you did something wrong. Let's find out. What's the square root of 91, right?
It's 9.5. I don't know.
It's pretty close, but it isn't.
9.5.
There it is.
Hey, Mrs. Colvin.
Okay.
It's a key and seal.
It's what? Okay, ready? Okay, it sometimes get a little harder. Find the amount of fencing in linear feet needed for the perimeter of my rectangular lot with a diagonal of length 13 and a side of 12. Well, what do I need to draw in here?
Diagonal.
A diagonal.
Put 13 on that.
Okay? I'll just draw the whole triangle. Oh,
Yeah, this is.
that works.
This is.
Okay, the diagonal is 13. One of the sides is 12. I'll make it the bigger side. Now, TJ, what's the other side? I look over here. I have a 12 and 13, and the hypotenuse is 13. You gotta be careful. That's 5. See, I'll show you what you have to be careful of. Okay, I'm not done though. So this is 5.
What happens if there's decimals?
Let's get decimals. This is 12. This is 5. And what's the side? 12. So what's the perimeter? Gotta answer the question. Zach, question?
I was at 4, so
Not right now.
34.
Have to do with this problem? No.
Oh, no.
So it's 2 times 5 plus 2 times 12.
34 meters.
10 plus 24. That's right. Is it meters? Yes. Okay. And farmers do use this. They have to fence their animals in. I had to fence my horses in. Once in a while, they get out. They don't want to chase horses. I did. They passed away now.
What are their names?
Lady in Sharia.
No,
Had.
This
They died. But has your horse ever escaped?
How old?
You go, they're gone. They pass away.
How old were they?
32.
Wow.
in dog years.
No, 32 in human years. So when your horses get out and you want to catch them, they don't have a halter on because they're free in their fence. So you go up to them and they're eating, and you get really close like this to grab their fur. Forget. Boom. No, mane. I grab the mane. Grab them around the neck, throw the rope around, and take.
224 dog.
Wow.
Pretty. The horses live a long time. My pony was over 40.
The pony was 40.
Over 40 years.
Stay a pony.
Different animal. Okay.
I thought
Oh.
pony was a baby horse.
Okay, you guys. There are miniature horses and there are ponies. Okay, shh. You guys, here's a triangle. This is 3, and this is, listen to me. This is 4. Is that side 5? No. So you have to be careful with the triples. You always have to get the hypotenuse. Has to be one of these numbers, and if it's not, then it's not a Pythagorean triple. So this is not. It's a square root of something. It's the square root of 7, actually. It's a little math. Okay. This is a homework problem, or if it's not a homework problem, it's darn similar. This is what we want. Okay, this is a hard problem. I want the area of that rectangle. Okay, Zach? This is 10, but I need this length. And here's my triangle. There's my triangle. I'm going to pull it out. That is a right angle. This is 20. This is 30. And I want the diagonal. Call it D. It's just hard to visualize. Other than that, it's not that bad. Use a calculator. Well, you don't need a calculator, do you? Because what? 20 squared plus 30 squared equals D squared. I need to find that length. 400. Cole, what's 30 squared? 900. Zach, what do they add up to?
It would add 1,300.
Oh, I forgot to answer that question. Okay, equals D squared. So what's D equal to? Square root of 1,300. Whatever it is. I don't care what it is. What's the area? What's the area? We're going to make this harder in a second. It's this length times 10.
It is 360.555.
I know, that's good enough.
What is 1,300?
Square root of it. Yeah.
The square root of that is 36.0.
Now, here's the next part that's hard. I want the diagonal of this rectangle I colored in yellow. I want this blue length. So if I pull that triangle out and bring it down, it's a right triangle. And we're starting to see some things three-dimensionally. This was still 10. What was this side? That was this side, right? Square root of 1,300.
306.
Well, I want to leave it that way because you know what? I want to find this side. Call it C. So C squared equals this leg squared plus this leg squared. So it's 100 plus, what happens when you square the square root?
It goes away.
It goes away. So this is 1,300. So that's equal to 1,400, right? I don't know what that value is, but C is equal to the square root of that. Sorry. 37?
Couldn't do it. Tried.
I don't know, I'll have to believe you.
Oh, you want to see?
I don't know, I'll believe you. Now, when you do these calculations on your phone, if you have an iPhone, you must turn your phone to its side to get the square root button. And you have to put the number in first, and then you have to hit the square root button. So it's tricky. Okay. Is that it?
Oh my god.
Well, that's it. Okay. Questions on this? Okay, let's look at homework. Oh, I should have it here. Okay. Okay, you guys. Homework. Which ones do you have questions on? Now, we can, this is lesson 5. I can do number 1 without any work. This is 8, 15, 17. Is it a triple?
8, 17.
Yes. So it's a right triangle. What about this one? Divide by what?
5.
Zach, what do I divide by here? What's common?
32.
Divide by what? 10. This is 13. This is 5. This is 12. Is that a right triangle?
Yes.
Yes.
And it's whatever pair.
Pythagorean triple. Okay? Now, this one. Where are the questions? I know there are questions.
Number 8.
But what about the first one? Are you okay with the first side? Callan, you got them all right? Are you okay with 8?
So do we write?
This is a right angle, so it's a right triangle. I'm going to pull it out. This side here is 1.5. This side is x. This side is 3.9. So you're going to have to use your calculator. X squared plus 1.5 squared equals 3.9 squared. So I know what 1.5 squared because it's 15 squared, which is 225. And there's a decimal in there. But I don't know what 3.9 squared is. Cole, do you know? Cole? Okay, it's 15.21. And then x squared is going to be equal to 15.21 minus 2.25. I don't feel good today, so I'm going to use my calculator because I'll probably do it wrong. And so I'm going to do this answer, enter, minus 2.25, and then I'm going to square root that. So I'm going to go second square root, and I don't want to type that in again, so I'm going to go second answer. You can do that on any 83 or 84. 3.6. Yeah. Question. If you don't have an 83 or 84, you got to do it. You got to write things down.
Yeah, I didn't have 83 or 84.
Then you got to write them down. This is 12.96. And then you square root that, you get 3.6. Okay. Any other questions on the front side?
Is it just yes or no?
And by the way, this is easy. This is 513. What's this side? Okay, Cole? It's 12. Okay, you probably did the work. I did the work on the answer key. I got to put the other answer key up. I haven't done it yet. I've done the answer key. I just haven't put it up. How about any of these? If you get stuck on 12 or 13, you draw a picture. And 14. 15 is the tough one. Zach, how'd you do 15? Mm-hmm.
All right. So if they are consecutive, they're consecutive holders. So there's 3 more on top.
No, they could be 5. It could be other things too. That's just guess. We have to do the work. Okay. Shh. Okay, you guys. These, well, you got a homework problem on this packet. Okay, Colin? These are consecutive integers.
That's not right.
10, 11, 12. Okay. Okay, girls, listen up. If the first one is x, what's the next one? How? X plus 1. This is one bigger than that. If I want to do this one, it's x plus what? 2. So you're not going to like this. This is x plus 1, or x. This is x plus 1, and this is x plus 2. Now we have to do the work. We have to use Pythagorean theorem. So you have to remember a lot of stuff here. Pythagoras? Look him up. Okay. How do we do this? A lot of you aren't watching, and you know I'm going to look for this problem. Okay? And if you didn't do it this way, it's wrong. Okay, Tess, where's your homework? Should have it written down. This is a hard problem. Okay, Zach? What do we know next? Zach, you should have your homework out. You should be doing it with me.
All right.
This is x squared plus, do I need parentheses around x plus 1? Sydney? Do I need parentheses around this x plus 1? I want to square it. Yes, I do. Because I want to square that number, whatever it is. That's equal to parentheses x plus 2. Do you guys remember how to square a binomial? That's why I'm doing this. Because the one that you have to do for tomorrow is even harder. So x plus 1 means this. Remember FOIL? First is x squared. Outer is x. Inner is x. And last is 1. Yeah, but you guess what? You have to know this next year. So that's x squared plus 2x plus 1. So let's put it in my little equation here. So I have x squared. Now put it in green. Plus x squared plus 2x plus 1 equals, okay, what's x plus 2 squared?
3x squared.
Nope. X plus 2 squared is x plus 2 times x plus 2. Remember FOIL, Sydney?
First.
So we multiply that, we get x squared. What about this? Plus 2x plus 2x plus 4. So that is x squared plus 4x plus 4. You have to multiply those out. That's why I said you need to pay attention.
I think so.
Okay, it's this side squared plus this squared equals the hypotenuse squared. You have to multiply that out. You use FOIL. First, outer, inner, last. You guys remember that?
Yeah.
Oh, I can't.
You have to. Now, I have an x squared on each side. Why don't I just cancel them out? I wish I could get them all out, but I can't. X squared plus 2x plus 1 equals 4x plus 4. Listen carefully. If you know this, girls, Tess, if you know this, you can solve any algebra problem. To solve any algebra problem, you always want it equal to 0. Always want it equal to 0. So let's subtract 4x first. Now, when I did my answer key, I didn't show all these steps. I just did it in my head. You got to get good like that. Only way you get good is practice. And that's minus. I always want it equal to 0 because I bet you forgot 0 product property. Okay, there's the beginning. Is that okay, Zach?
Yeah.
Then you have to square that out. There it is.
Oh, I get it.
FOIL. And I showed you all the work. Not on my answer key. But I will save this lesson. And so we're going to subtract 4 from both sides. I think. So x squared, no, I won't, minus 3 is equal to 0. Now we have to remember how to solve a quadratic equation. You always want it equal to 0 because we'll use the 0 product property, which says that if you have two numbers, if a times b equals 0, then what's got to be true? If I'm thinking of two numbers and I'm thinking of two numbers and the product is 0, what's got to be true about one of the numbers? Has to be 0. Okay, TJ? So either A equals 0 or B equals 0. Okay? Guess what we have to do? We have to factor that. That's not multiplication. Okay, girls? Do you remember the X game? Now, I don't know in the ninth graders if you did the X game. It's very easy. It only works when A is 1. Now, you could use quadratic formula, but that's kind of painful when I can factor it. The X game says you put the negative 2 here, and you put the negative 3 here. This is how I'm going to factor it. Those of you who are in quadratic, oh, you didn't see because I didn't do that last year. I learned it this year. Now, what two numbers multiply to give you 3?
7,
What times what is 3?
3,
3 times what? 1. Now, I want a negative 3, which means that one of these has to be negative. But I want to get a negative 2 when I add them.
It's -3.
So it's negative 3 and positive 1. So this factors be x plus 1, x minus 3 equals 0. And because the product is 0, then either this one is 0 or this one is 0. Well, you know what makes this one 0, don't you? What can I put in there to make it 0? 3. This one's harder, but it's not that much harder. What can I put in there? Negative 1. Now remember, what did x stand for? X stood for the side of a triangle. So can the side of a triangle be negative? Yes or no? Can the side of a triangle be negative? No. I've never seen a negative side in my life. Okay, we haven't answered the question yet. And Zach was right, but I have to do the work to prove Zach's right. Zach, this is 3, this is 4, and this is 5. But you have to do the work because it may not always be nice. Turned out to be nice here.
So I actually guessed it right out of all the consecutive integers. That's gotta take some skill. Maybe I can.
No, it's probably the only one. But now, what the next one you have consecutive even integers.
That's like a skill you could have guessed, but there's like a one.
Now this is just straight old algebra. Yeah, you like geometry better? I like geometry better. What? Okay, are there other ones you want to look at here?
I still don't get how we're supposed to figure out all that stuff.
If you have to do the work. Yes, that's right. You have to use your brain. Now, I want to say something about this one I did yesterday. Those are not congruent. E and F. It looks like they are, but they're just trying to define the angles. And this is a tangent, so guess what? E is 90 degrees. This is a tangent, so that's 90 degrees. And go in alphabetical order, because this forms a linear pair. So A plus 58 is equal to 180. And you, no, this is review. You didn't do your homework last night, did you? Oops. Okay, subtract 58 from both sides, and you'll get that. Well, just keep working around it. You know how big C is. How big is C? What kind of angles are these? TJ? This is C, this is 106. No?
Yes.
They're vertical. Do you see the V?
This is how you do this one.
This is a V. So what's C? 106. But if you go in alphabetical order, it's easier.
We'll have to do any of those problems.
On the final. So we are going to have several review days. And then Tuesday, I'll give you a Schoology quiz. Which will be like, well, the final can't be terribly difficult. Can't be as hard as that. Can't be. That's too hard for a final. Did anybody figure out why m plus n isn't 120? Well, I've got it written down. Other questions on homework? So you need to be working on this. I'm going to come around and see what you've gotten done. And I'm done with this.